Good evening, everyone, and welcome to GDSC's Game Design Jam with REST APIs. Before I get started, can everyone hear me okay?
Yep, I can hear you great.
Okay, let's get started. So please just make sure that you're checked in through our official website, and yeah, let's dive right in. An application programming interface, or API, is a set of protocols and definitions for building application software. In general terms, if you want to interact with the computer or system to retrieve information or perform a function, an API helps you communicate what you want to that system so it can understand and fulfill the request. A major advantage of an API is that you don't have to know the specifics of how your resource is retrieved or where it comes from. An example of an API is the upper method for string handling in Python. When the user uses the built-in method to convert a string to uppercase, all they have to do is call the method. They're not actually concerned with how the method works or what code goes into actually implementing the API. All the user is required to do in order to get the desired results is use the API. Okay. There are different kinds of APIs, but the ones that we're concerned with for the purpose of this event are REST APIs. So let's talk a bit more about that. REST, or representational state transfer, is a set of architectural constraints. When a client request is made via a RESTful API, it transfers the representation of the state of the resource to the requester or endpoint. This information or representation is delivered in one of several formats, such as JSON or JavaScript object notation, which we would be using today. An example of an API design that you might encounter in your daily life is the API design of a weather app. So for example, a weather app could require the user to supply a zip code. And based on that information provided, the weather app would reply back with a two-part answer, the first being a high temperature and the second being a low temperature. This is basically how RESTful APIs work. Now that you know what a RESTful API is, the question is, how do you implement one in Python? To be able to use a RESTful API in Python, we use a native Python library called the requests library. But before we talk about the library itself, let's talk about what an HTTP request is. An HTTP request, or a hypertext transfer protocol request, is made by a client to a named host, which is often located on a server. The aim of the request is to access a resource on the server, and the request is made using the components of a URL, or a uniform resource locator, which includes information needed to access the resource. Okay, so this is a snippet of how the request library works. The request library basically makes it easier for a user to send HTTP requests using Python. For the purpose of this event, we would only be using the get method of the requests library, but after the presentation, I'll be sending a link to the official documentation in case you want to explore it further. Now, the request library is not pre-installed. So using the command that is mentioned in the slide, you have to install it on your desktop, and then you can just import it and use it like any other library. In order to use the request library, you have to make a request. So how does that work? So using the get method, you supply the URL of the API that you're trying to access in the form of an argument, a string argument to the method. And the data can be stored in a variable, which can then be processed and manipulated to get whatever result you want. So we know how to retrieve data using the request library, but how do we display it, or how do we process that data? So this can be done using JavaScript object notation, or JSON. JSON is a pre-installed library in Python, and using the .json method, you can just convert the data that has been retrieved using the API in the form of a Python dictionary. Since the data is displayed in the form of a Python dictionary, it can be manipulated and processed using the basic dictionary commands. And that is it for the general introduction. Let's move on to the details of the event. So for the event, you're required to build a game in any programming language of your choice using the Deck of Cards API. The submissions will be collected through a Google form using the two links. You are first of all required to publish your project in the form of a GitHub repository. And along with the link to your GitHub repository, you will be submitting a 3-minute video presentation demonstrating your team's game. The submissions are due this Sunday, February 27th at 11:59 p.m. and a link to the Google form will be sent in the chat. And let's move on to the judging criteria. So in order to win the prize, which is $50 for a maximum of $50 for each team, there are certain design goals that your team is required to achieve, with the first or the most basic one being that you have to make a card game, which is a working command line interactive card game, and you have to use the deck of cards API. If you're able to achieve this, you will be winning the base amount of $10. But on top of that, if you manage to integrate the API's shuffling and draw a card feature, you win an additional $5. If you integrate the API's piles feature in any form, an example could be just referring to each player's hand as one single pile, you would be winning an additional $10. Apart from that, based on the creativity and uniqueness of the game design, there's a $15 prize. And based on the neatness of the user interface and the degree of user interaction, there's an additional $10 prize. For mentor support, if you don't already have access to our Discord server, make sure you access it. We have mentors who can help you with implementation of the APIs in multiple languages. So feel free to check that resource. And that's it for the presentation. For those of you who already know how to use dictionaries in Python or how to implement RESTful APIs, feel free to skip this part because I'll just be coding a sample program. We'll be making a simple game. So let me just reshare my screen. The game that we'll be making here is, first of all, we'll be using the RESTful API, of course, and we'll be drawing a card and we'll be telling the user what the current card is. And then we'll be asking the user to make a guess, which could either be a higher or lower card. And if the user guesses it correctly, the game would keep going. But if they get a wrong answer, the game would stop. So let's get started. First of all, you have to install, you have to install the request library. I'm going to do that over here. Once that is done, we would be importing the request library. Now, there are different functions that I want to create. Let me give you a walkthrough of the page first. Okay, so this is the deck of cards API webpage. And over here, you can see you've been given different URLs for accessing each feature. And below that, you've been told what a sample response would look like. So for example, if you're using the Shuffle the Cards API, a sample response would be a dictionary with four key value pairs, and you can use these pairs, or you can use these values to create your game. The functions that I want to make are, first of all, I need to generate a new deck. I would be shuffling the deck and then drawing a card. So let's start by creating a deck. Response will be the variable where I store my data that has been retrieved using the request library. And let's get our generate. Yep, here we go, a brand new deck. I'm just going to copy this URL and pass it as a string argument to our method over here. And then as you can see over here, once you generate a new deck, the data that you receive includes these four keys: success, deck ID, shuffled, and remaining. The value that I need to access is the deck ID because I'll be using the same deck ID for all of my different functions. So for that, I can just return response.json. And then the key that we're trying to access is deck ID. So deck ID. And that's all you have to do. Let's move on to the next function. Let's shuffle our deck. We're using the same approach over here. We're using a variable to store the data, and we're going to use the get method. I'm going to replace new over here with ID in curly braces. So we know that we're using the same deck ID for all of our functions. And what I want from this function is, let's try something. So I want the deck to be shuffled only if the API has been implemented successfully. This isn't necessary, but just for the purpose of great clarity, let's try writing a condition. So if response.json, and we're looking for success. So if the value of this key success is true, I want my function to say the deck has been shuffled. Else error encountered while shuffling the deck. And that's it. Now let's move on to our main feature, drawing a card. So draw a card. We're following the same approach again. And let's get our URL for drawing a card. I'm going to again replace deck ID with curly braces and supply our own ID over here. Now, the response that you get from the draw a card feature is different. So instead of getting just a simple one-word value, for example, for cards, you get an array of 2 dictionaries. So each dictionary contains 4 keys: the image, the value, the suit, and the code for each card. The values I will be using are value of the card. So for example, kings, a king or 8 or 6. And the suit would be either hearts, diamond, clubs, or spades. So what I want to do here is I want it to return 2 values. So response, the values that we want are the values of the key cards. So I'm going to write cards for the first item in the array. So we're just accessing the first dictionary over here. So the index and then value. And the second value that we need is the suit. And that is our draw a card feature. Let's write our main function and get all of this together. The first thing that I'm going to do is I'm going to get our deck ID. So I'm going to call the generate deck function and store the returned value in deck ID. Then I'm going, and then I'm going to shuffle our deck. So once the deck has been shuffled, I want to draw a card, and we're going to call this the current card. And we've got the current card over here. Before we move any further, let's first define the values for some of the cards. So ace over here will have the value 1. Jack will have the value 10. Queen will have the value 11. And king will have the integer value 12. Okay, now that this is done, let's start our while loop. So play is true, while play. What we want to do over here is we want to tell, first of all, we want to tell our user what the current card is. So the current card is, so we're going to print the value of the card first. So current card of type okay. So we know what our current card is now. So let's go ahead and ask our user. So we're going to ask a user to make a guess. So enter H for guessing higher, L for guessing lower, and Q for hitting. Okay. Okay. So then we're going to read our, we're going to draw our next card first. So the next card, we'll be using our draw card function again. And we're going to compute the values, the integer values of our current card and our next card. So we want this to be an integer value. Our next value will be okay. We've computed our integer values. Now let's check the user's response. We're going to create different cases. The first case would be if the next card and the current, so if the next value and the current value is the same, so let's account for that. If the current value is the same as our next value, we're going to tell the user that skipping this turn because the value is the same. And I forgot to display the value of our next card. So let's do that first. So the next, the card is okay. So we've told our user what our current card is. We've asked them to enter their guess. We've told them what the next card is. Now we have to check if they got the answer right or wrong. So let's do that. If the user guessed higher, there are two cases. So either they guessed it right or they guessed it wrong. The user got it correct. So we're going to make our current card the next card. Now, what if the user got it wrong? If the user got it wrong, we want the game to end. So I'm going to set play as false. Now, what if the user guessed lower? So let's account for that case. There are again two cases. They either got it right or they got it wrong. So Again, we want the game to be over, so I'm going to set play as false. And the last case is if they want to quit. So this should be it. Let's try running it, see if we have any errors. Okay. Let's call our main function then. Okay, so the deck has been shuffled. The current card is 7 of hearts. So let's guess higher. Oops. Current one, yes. No. Oh, wait. Okay, never mind. Values, we have to access these values from the dictionary that we defined earlier. Okay, so we entered higher, but the card was 8 of diamonds, so it did not work. Let's give it another go. Let's get slower this time. Okay, let's give it another try just for the sake of it. Higher. The current card was 4 of hearts. The next was 5 of spades. So I'm just trying to see if it keeps going. Okay, yay, we got it right. So the card was Queen of Hearts and we guessed higher. The next card was 9 of Clubs. So let's guess lower now. And again, yeah, this is basically how the game will work. Does anyone have any questions? Okay, I'm gonna take that as a no. And I'm gonna stop sharing my screen.
All right. I just want to remind everyone that for the submissions for the actual game jam is not to recreate what Sumania just demonstrated, like that card game. You kind of the goal is to come up with your own card game. Like maybe there's one like already exists and you want to recreate it by coding it in, or you can also design your own card game. But the point of it is to use the deck of cards API and submit some kind of project as your game jam project. But yeah, that's it.